Hi everyone, I have Bella here with me to learn the quadratic formula. Want to say hi?
Hi.
All right, so we're starting lesson 9.5. We're passing over lesson 9.4. It's on completing the square. If you want to learn it, you can. It's not part of the Algebra 1 curriculum, so we would have skipped that in school as well. But you will go over it in Algebra 2. So it's something you cover in Algebra 2 based on the standards. But let's review a little bit about what we've covered so far. So we've talked about factoring when we see something of this form, ax squared plus bx plus c equals 0 or not equal 0. We've talked about solving by completing square roots, and that's when we're missing that x term, this bx term that was there before that's not present in this scenario. So solving square roots works great. But now we're going to talk about a method called the quadratic formula, and this works all the time. It's a process that uses a formula. That's why it's called the quadratic formula. It's based on quadratic equations, and there's a lot of programs that can easily do it for you. You'll just type in the ABC values, like calculators and stuff. So you're always, when you get higher up, you'll probably get a calculator that just does it for you. But it's important you understand how to do it and what it's saying, what it means. Okay, so first of all, there's this little picture here. Here's what this decodes to be. So x means the x-intercepts. When it says x equals, just like we're always doing, we're solving for the x values. So x equals, now this b here is angry, so it's like a negative b plus or minus the square root. Here's a b inside of a square, so this is b squared minus, and this is an air conditioner, and sometimes air conditioners are considered AC, like, oh, how's your AC working? So 4AC. You may not understand that reference, but that's okay. All over 2a. So that's a really long formula, and there's a lot of letters, and it seems very arbitrary. And there's actually a way to derive it, but you have to know how to complete the square, which is that lesson 9.4 that we skipped. So I can't show you that derivation unless you want to kind of learn that process, and you can reach out to me separately. But that formula is something we want to memorize. So what I'm going to pull up right now is a little song, and I don't know if the song, you're going to be able to hear it or not. I have my sound up all the way, and I'm hoping you can. But if you can't, what I'd like you to do is Google it on your own, and then you can listen to it yourself a couple of times until it's kind of stuck in your head. In class, we would have probably have listened to it like 5 times, so you'd be singing it all day. But here we go. We'll just do it once. So there's a bunch of versions. I have the quadratic song. All right, so there you have it. Now, if that didn't work for you, that's okay. Again, I would encourage you either to try to Google that. I pulled the song. It says quadratic formula song, Rockford Christian. Someone in class last year or the year before shared it with me. But you can Google a bunch of different ones. I just want you to try to have this memorized. And I know it's long, and I'm not going to obviously test you on it because of our circumstances, but I want you to have that in your head. Okay. All right. So here's the formula, the core concept. Okay. They show the formula again without all those crazy pictures. They put a few restrictions in. They say a can't be 0, and that's because you can't have 0 in the denominator. And they say that this expression is actually what shows up here under the square root. This value here has to be greater than or equal to 0. So it has to be a positive value. Okay, we're going to talk about that later. But I did pull in a little picture of Peppa, compliments of my kiddos. They were watching this a year or so ago, and whenever we watched it, I might even make the picture a little bigger. Papa Pig is at his work, and it's kind of blurry now, but this is negative b plus or minus the square root of a triangle all over 2a. And in yellow here, what you can't see is that they have triangle equals b squared minus 4ac. So this is one of those formulas that they throw out a lot that make it look really complicated, but you're going to see in just a second, it's actually pretty easy to use, okay? Again, this formula works all the time. So factoring works sometimes, square roots work sometimes, quadratic formula works all the time, but it can be a little cumbersome. So let's try one. All right, I'm going to move this graph off to the side here. So they want us to solve this quadratic equation. Okay, so it has equals 0. Everything is on one side. I can't use square roots because there's an x term, so that option's out. I might try actually factoring, in which case I would say 2x and x. Two things that multiply to give me 3 maybe would be 1 and 3. And then it multiplies, they add to give me a negative. So let's make this a -3 and a +1. And let's see, does that work if I FOIL first? It's 2x squared, outer is 6x, inner is 1x. Oh, and I get -3. But let's see. I could keep working with this, and I could see if it's factorable, and it might be, but it might not be as well. So what I'm going to try, maybe you have it if it is factorable, but I'm not focused on that method right now. What I want to really emphasize is the quadratic formula. Okay, so what I was getting at is that you can go ahead and always try to factor. You can always see if that works, and sometimes it will, like you saw in past homework, sometimes you can't. And when you can't, the second option you can fall back on is this one. Okay, so let's see what I just wrote. All right, so what I wrote here is the standard form of a quadratic equation, ax squared plus bx plus c. So these values align. So my x squared term, the coefficient there is my a. The coefficient with the x term is my b, and the constant on the end is my c. So I'm able to label that a in this case is 2, b in this case is -5, and c in this case is 3. Okay? All right, so now what I'm going to do, and I pulled it up so we can see this formula up here, is now I'm just going to apply everything to the formula that they've given me. Okay? So it's going to be x equals, and all I do is substitute everything into the formula. So it's a -b. Now I like writing it like this because notice the formula is -b. So it doesn't matter what b is, it's always the opposite of that. So b in my case is -5. So I'm going to write negative, and then where b was, I'm putting a -5 in that spot, plus or minus the square root of b squared. So that's -5 squared minus 4. My a value in this case is 2. And my c value is 3. And I put all of that over 2a. My a value again is 2. So just looking at it, I'm going to highlight first my a's, just so you can see where I got these values from. So a was 2, and I had to put a 2 here and a 2 here, and that's what you'll see here and here. Okay. My b value is -5, and in my original formula, b's show up here and here. So I have -5, -5. And then the last thing, my c value is 3, and in the formula, c shows up at the end, and that's 3. Okay, everything else is part of the standard formula. It's the negative right here, the plus or minus, the square root, the squared, the -4, all over 2 times my bottom value. Okay, all right, so now let's just simplify. I'm going to simplify the numerator first. -5 is +5. Plus or minus, let's simplify what's inside. -5 squared is +25 minus 4 times 2 times 3. 4 times 2 is 8. 8 times 3 is 24. Okay, and now that's all over 2 times 2, which is 4. So this is what my new equation looks like. Let's continue to simplify what's under the square root. So now I have 5 plus or minus the square root of 25 minus 24. 25 minus 24 is 1. That's all over 4. Okay. So now what I'm going to do is take the square root. That's my next step. The square root of 1 just is 1. But like we saw in our last lesson, it could be positive or negative, and that's the reason they put this plus or minus here. So we don't need to take that into account. They already have. Over 4. And this is when I'm going to do it in a different color. I can branch into 2 different equations. I'm going to do 5 plus 1 over 4, and I'm going to do 5 minus 1 over 4. And these are going to be my 2 different answers. 5 plus 1 is 6, 6 over 4, which is 3 over 2. 5 minus 1 is 4, 4 over 4 is 1. So my 2 answers are x equals 3 over 2 and x equals 1. Okay, I know that seems kind of long, but it will go faster once you've done it kind of on your own a few times. Let's just pull in the graph so we can see. Notice, here's where it crosses the x-axis. 1 and 1.5. That's what 3 over 2 is. So again, we could have factored this. I might have just made a little mistake when I was doing it, but that's probably very possibly factorable, but not everything will be. So let's move on to the next page and just try a couple more together. Whoa, sorry. Okay, so I'm going to write the formula every time we do it. So this is my A. First, I'm going to say my A. It's the 1 here. My B is the -6, and my C is the 5. Okay, so x equals -b plus or minus the square root of b squared minus 4ac all divided by 2a. And I encourage you to write that every time as well. The more you say it in your head, the more you'll get it. So -b is -6 plus or minus the square root b squared, so it's -6 squared, minus 4, my a is 1, and my c is 5, all divided by 2a, so it's 2 times 1. All right, simplify everything we can. -6 is +6, plus or minus, I'm going to get 36, there's -6 squared, minus 20, all over 2 times 1 is 2. All right, so now I have 6 plus or minus, 36 minus 20 is 16, all over 2. I'm going to take the square root of 16, so 6 plus or minus 4 over 2. And here's where I branch it into the 2 different options. I'm going to go 6 plus 4 over 2 and 6 minus 4 over 2. 6 plus 4 is 10 over 2, which is 5. 6 minus 4 is 2 over 2, which is 1. So in this problem, my 2 answers are x equals 5 and x equals 1. All right, I have 2 more that I'd like to do with you, so I'm going to keep rolling. My a value here is 1/2, it's the x squared term. My b value is 1, that 1, and my c value is -10, it's my constant. All right, let's go ahead and write the formula out so that we can substitute everything in. X equals -b plus or minus the square root of b squared minus 4ac, all over 2a. All right, subbing things in, I'm going to get x equals -1 plus or minus the square root of 1 squared minus 4 times 1/2, because that's a, and c is -10, all over 2 times 1/2. Okay, all right, so simplifying a little bit, -1 plus or minus the square root of 1. 1 squared is 1. Now, 4 times 1/2 times -10. So let's multiply those together. 4 times 1/2 is 2. 2 times -10 is -20. All righty. And then my denominator, 2 times 1/2 is 1. Okay? All right, so -20 is going to make this, underneath my radical, +21 over 1. Okay, so I'm going to branch it into my 2 different options, and that's going to give me -1 plus the square root of 21. I don't really have to write over 1, but I can. And -1 minus the square root of 21 over 1. So my 2 answers are, I'm going to do -1 plus the square root of 21, and I get 3.58. And then I'm going to do -1 minus the square root of 21, and I'm going to get -5.58. This is an example of one that would not have been factorable. Okay? All right, I'm going to scroll on to our last ones. You could check that on Desmos if you'd like to see it, but let's just, in time's sake, A is -3, B is going to be 2, and C is 7. All right, so x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So x equals -2 plus or minus 2 squared minus 4 times -3 times 7, all over 2 times -3. All right, simplifying what's underneath the radical, I have -2 plus or minus. All right, 2 squared is 4, and now I'm multiplying these values here together. So 4 times -3 times 7, 4 times -3 is -12, and 12 times 7 we know is 84. So it's minus -84 all over -6. Okay, and then you can take it from there, but we're